Good morning, everybody. Welcome to this new lecture of the series Big Data for Engineers. Today, we are going to finish on the syntax. I showed you JSON. We're going to look into XML. I also wanted to say that we are going to still try with the hand microphone. We do have it in the room, right, Wenxi, the hand microphone?
Yes, if you have a question, please raise your hand and I can hand this to you.
Exactly. We have the authorization to circulate it. I think that last week, the possibility wasn't really used, but you should really make use of that. We tried it in another course last week on Friday. It worked wonderfully. And we are also going to try on Zoom to unmute you. So if you want, instead of writing to the chat, you can, of course, write to the chat and then when she will repeat. But you can also raise your hand by clicking somewhere right here on reaction and then on the raise hand, and then we know that you want to ask a question, and then when she will be able to unmute you, and you can. This is all with the understanding that this is this is recorded and it will be publicly available. So if you are uncomfortable, just ask without any microphone, and when she will just repeat. All right. Then let's start with the continuation of what we did last week. So I'm going to go into XML. So I have a word of warning. XML is more complex than JSON. And actually, this is probably why JSON is actually growing in popularity these days, and a lot more data sets are in the JSON format. And XML is nevertheless still here. And there are data sets out there in the XML format. Actually, a lot of data sets are in the XML format. It's still used today in the corporate world. For example, tax certificates in Switzerland are issued in the XML format embedded in a QR code. That's just an example. So you have to understand XML. But of course, don't worry, not all of it. It's too complex. So I'm just going to scratch the surface of XML. I'm just going to show you the most important constructs. I'm going to relate it to JSON, and then you'll be fluent at reading these XML data sets. Then I'll say a few words about namespaces. And again, I'll try to keep it understandable, but we'll take the time to go through this and understand everything. So first, you remember, just to remember from last week, in JSON, we have 6 building blocks: objects and arrays. These are the structures. And then we had strings, numbers, booleans, and nulls. This is all there is in JSON. Okay, so let's dive into XML. Well, XML is also sometimes referred to as the tag soup, the soup of tags. What is a tag? Well, it looks like this. It has these little angle brackets. You see, so in JSON, you have the curly braces for the objects, and you have the square brackets for the arrays, right? Well, in XML, you have what is called an angle bracket, like this. It's just like the smaller than or greater than, but it doesn't mean smaller than, greater than. It's just a tag, right? It just looks nice somehow on the screen. So this thing right there is a tag. It's actually an opening tag, and it is closed over there. That's called the closing tag, right? How you see it's the slash right there, right? So this is a bit the equivalent in JSON. When you have an object, you open the object with a curly brace, you close it with a curly brace, you open an array with a square bracket, you close the array with a square bracket, and then you put stuff inside. Well, here it's the same, but the difference is that the opening and closing thing have a name, and that name is foo. So this is start of foo and end of foo, basically. And we are super lazy in computer science. So if we have nothing in there, it's just like that would be an empty array on an empty object in JSON, where in XML, it's an empty element. That's called an element. We are super lazy, and we just use this shortcut here that looks like a tag here, but the slash is at the end. This is just a shortcut for open, close, but without anything in between. Right. So that it would also be fine to write it that way. It's just because we are super lazy in computer science. We are paid for being lazy, actually, to automate and optimize everything and save space. All right. So this is called an element. An element is opening like this and closing like that, and it has stuff inside. What stuff? Well, it's exactly like JSON. You can put anything in anything, right? Just like you have objects in arrays in objects in arrays in JSON, then in XML, you can have elements in elements in elements in elements and nest arbitrarily. All right, that's the first thing we have in XML, the elements. The second thing we have, it's called an attribute. The attributes belong to the opening tags or empty tags, so either here or here. After the name that would have been foo before, now it's a, there is a space, and then you can put key value pairs like that. So this is the name of an attribute, and this is the value of an attribute. So the name of the attribute without quotes equals, and then quoted the value. All right, so this is called an attribute. You can have as many attributes as you want in the same element, right? All right, so here you see it looks actually a bit like in JSON, the key of an object and the value of an object, right? So in JSON, that would be a colon, but in XML, it's an equal sign, right? But this is the idea that within that opening tag of an element, you have these key value pairs. These are called attributes. All right, so we have elements, attributes. What's next? Text. Text is just text. I don't think I can say much about that, but the one thing I'm going to say to compare to JSON is in XML, in the syntax, we don't even know about numbers, booleans, and everything is a string, unquoted. So it's just text, 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 text. That's all there is. So when you want text, you just put the text right there like this, right, without any quotes, and this is just text. If you have numbers, you would just put them like text in the same way, right? XML doesn't even know about these things on the syntactic level, all right? Some of you might already be familiar with HTML, right? Can you raise your hand in the lecture hall, those, or maybe also in Zoom, if you raise your hand, who is familiar with HTML, has already seen HTML? A lot of you, right? So it's going to be super easy to learn XML, right? If you already know HTML, probably already recognize a bit the syntax. Okay, so now you can lower your hand. That's just so we can see if somebody wants to speak. Thank you for that. So how is XML different from HTML? Well, it's just that it's more strict than HTML, because you might know that, for example, in HTML, it's fine to not have a quote. In XML, you need it, right? So it's much, much stricter, and you always must close all your opening tags in XML. In HTML, it's a bit more lenient. You don't have to. In XML, you must do that. All right. So element, attribute, text that you put just between the tags, right? Not in the tag, between the tag. And then finally the comments, well, it's just like you have comments in C++, in Java, and so on. Typically it's // for comments, or /* and // it depends on the language. Well, in XML, this is how comments look like. They have also like angle brackets, but with an exclamation mark here. This is how you know it's a comment, and then double dash, and then double dash. So now you're going to tell me, okay, this is ugly and complicated. Well, this is for historical reasons, that there is actually an old language called SGML, and XML actually is a simplification of SGML. And these are kind of the remnants of the SGML language. What is the main application of all of that? It's the publishing industry. And that shouldn't surprise you, since you see the proximity with HTML, because HTML is for web pages where you display something on a string. With images and titles and headings and so on and so on. Well, the publishing industry loves XML. There's a lot of scientific papers and books written in the XML format, even Word, Excel, and so on. They all store everything in XML. You can try, if you want, by the way, try to change the, take an Excel file or a Word file and change the ending with .zip instead of .xslx or docx. Rename it to zip, unzip it, and look inside. And guess what? This is what you're going to see. It's everywhere. It's going to be XML. Right. Okay, but it's going to be very large and very scary, so do not let yourself be scared by that. All right. Well, I have good news, because that's all I'm going to show to you. Elements, attributes, text, and comments, and that's it. Right. There's more, but I'm isolating you from this. This here, I didn't even count it. This is just some paperwork that you can put at the start of your XML documents, almost exactly like that, that just says, okay, this is XML version 1, and this is the encoding, meaning it's the way it's stored on the hard drive. But this is not really part of the XML file. It's just a declaration that self-declares as XML, kind of. It tells you that this is XML, and so this is what you find at the beginning of an XML file, but it's optional. But again, it's always like this. You really don't have to learn it or anything. You just need to see, okay, that's version 1, and that's the encoding, and that's it. All right. Okay, so this here is an XML document, a well-formed XML document. How can I see it? There is here an element, foo, and that element is empty. How do I know? Because of the slash at the end. That's equivalent to opening, closing, and without anything in between. All right. I always must have in a well-formed XML document exactly one top-level element like that. So this is well-formed. This is why I put the little tick in there. This is well-formed. This is well-formed too, because this declaration right there is actually optional. You don't have to do it if you don't want to, so this is just fine too, right? So this is also a well-formed XML document. So far, so good, right? This here is not a well-formed XML document. Why? Yes, on the Zoom chat?
Yes, the Zoom said there's no root.
Yeah, exactly. There is no root, there are two, and that's not okay, right? You have 1 and 2. Right?
Yes.
Is there a comment in the lecture hall? Yeah.
Not in the lecture hall, but the second chat said there's one top level.
There should be 1, exactly. There should be exactly 1. So this is not okay. This is okay, sorry. This is okay. This is not okay. There are 2. This is okay. Why? Because there's only 1. That's foo. Foo is that's the opening of foo, and that's the closing of foo. But there's only 1. That's foo. And inside foo, what do we have? We have bar, which is an empty element. So we have bar inside foo. That's just like in JSON, where you can have objects in arrays in objects in arrays. Here you can have elements in elements in elements in elements. All right. So here it's well-formed because we have only 1 at the top level, that's foo, and here we have bar. You notice the little spaces there and the new line and so on. That's just for us humans. When you are a human and you look at JSON or XML, you love it when you nicely format it. That's called pretty printing, but it doesn't have to be, right? So I could also have put it all on the same line. But as a human being, I like to see nice XML or nice JSON. So this is why here there's the blue line, and we even put two spaces to make it even more visible that bar is nested inside foo, and then we close on the next line, right? But this is just for us humans, really, that we do that. Okay, this is not okay. Why? Because I have text in there that is free floating without any element. It's not even inside an element here and there. That's not okay. Text must be inside an element. It cannot be just outside like that in the wild, okay? This is fine. Here, look at what we have. We have 1 single top level element foo, and inside I have text, I have an element bar, and I have text, and that's all fine. Just looks like HTML, doesn't it? Okay, this is not okay because I have here an element inside a tag. I cannot have an element inside a tag. It must be between the tags that I have my nested element. So this is not okay, right? Okay. This is also not okay because here I'm nesting an element as an attribute value. I cannot do that. This is not allowed. You cannot have this character in an attribute value. That would confuse the parser, right? So that's the reason. All right. So you cannot use these characters, but this is fine. Right? You can just put it that way. Okay. What you might see, and you probably saw it in HTML, is that sometimes these top level elements that you have, there is an additional doc type declaration, but it must be exactly the same name here. That here must be the name of the document. What is it for? I have no idea. Well, I do know, but I don't want to annoy you with that. It's really just a declaration, just like this is a declaration that this is XML. This is a declaration that the top level element is called document, right? But even without that, you would know because you see it, that's the top level is document, right? All right. In an HTML document, you would see doc type HTML, right? Okay. So this is a summary of what appears where. Elements appear only once at the top level, exactly once, any number of times between the tags, and never inside an opening and element tag. Attributes only appear inside an opening or empty element tag, never in the wild. Otherwise, they wouldn't be recognized as attributes. Text can only happen between element tags. If you see text in an attribute, that's not text. That's really just the value of the attribute and the name of the attribute, that this is not called text. Text is what is between the element tags, right? Okay, so this is my summary. Okay, so now a bit more fine tuning to tell you what's okay, what's not okay with XML. Here, that shouldn't surprise you because it's like JSON, actually. In JSON, you cannot have duplicate keys. Well, here, you can also not have duplicate attribute names in XML in the same element. Right? If it's another element, that's fine. Foo, not okay. Collision. You need to have distinct names, right? So this is an element that has 2 attributes, foo that has the value bar and foo that has the value bar 2. That doesn't work. Here, this is correct. It has an attribute foo with the value bar and an attribute bar with the value foo. By the way, you might be wondering, if you're not computer scientist, why do I put foo and bar everywhere? it's actually a computer science geek stuff. It comes from the German Furchtbar, and that became, you know, what when we need a name for anything in data, we just call it Foo and Bar. All right. Okay, this here is not well formed. Why? Because you see that I'm opening A and I'm opening B, but I'm closing A first. That doesn't work, right? You really need to nest. So if you open and close A, you must close B within A, right? So it's just a matter of consistency, right? It's like, I don't know, an example, if you enter into a building, you open the door of the building and then you open the door of a room, then you first leave the room and then leave the building. You cannot enter the building, enter the room, leave the building, and then leave the room. That doesn't work. That doesn't make any sense, right? So this is really the idea of well-formedness. When you nest an element inside another element, you must open and close that nested element inside the outer element, right? So this is the idea here. Do we have a question?
Yes. So the comment says attributes are useless if we can't nest nest elements inside them. They
seem useless, and in fact, you could technically replace all attributes with nested elements, right? But nevertheless, whenever you need a key value model, and you don't need any nestedness, and the values are just atomic, just like strings, numbers, and so on, except XML doesn't know that these are numbers, then you can use attributes. Elements is whenever you want to nest, then you need elements, all right? Now, you need to be aware that this whole discussion, or do I need an element or an attribute for my data, that's the best way to trigger a troll on the internet. If you go to an XML forum and ask the question, are elements or attributes better? Expect 1,000 people who start arguing on whether elements or attributes are better. You can even try to Google for that. You will find plenty of these forum threads, right? But the main difference objectively is that attributes cannot nest and elements can nest. I'm not sure if I answered your question.
Not yet.
Yeah, awesome. Okay, now, in order not to confuse the parser, you can also not use that character in your text. Why? Because the parser would be confused. The software that's reading your XML, it would believe that this is the opening of a new tag. You cannot do that. You need to escape it with this absolutely horrible sequence of characters that is the ampersand LT semicolon, lower than actually. LT is for lower than. This is called an escaping. That's just like the backslash, when you say backslash n in JSON or the new line. Here it's an escape of that. That basically means this is actually this character, but since I'm not allowed to write it directly, I just escape it in that way, right? Ampersand, by the way, is called ampersand. I like to tell this anecdote. It used to be the 27th character of the English alphabet. There's a few characters actually disappears, a few letters from the alphabet. And in the 19th century, when the children would recite the alphabet in school, they were like ABC, blah, 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 X, Y, Z. And then they needed to add this symbol. But if you just say this is called end, it's a éperluette in French for end, you would say X, Y, Z, end. And that sounds odd. So what they said is instead X, Y, Z, end per se, end. And then by saying it quicker and quicker and quicker, X, Y, Z, and per se end, it gave ampersand. So this is why it's called ampersand historically. All right, but anyway, now you will remember the ampersand in the way we escape. Okay, now good news, there's only 5 to learn, not more than that. LT is one of them. You have GT greater than for this character, apos for the apostrophe, for escaping the apostrophe, quote for escaping the quote there, and ampersand for escaping the ampersand right there. All right, so these are called entity references. It doesn't actually matter what they are called actually, but this is used whenever you want to escape. Here's another example. You can, for obvious reason, not use this quote character inside an attribute value because that would be confusing, right? You would believe, okay, that's the end of the value here. So what you need to do is use what I showed you here, quote for the double quote, and then escape it with ampersand quote. It's exactly like in JSON, you have this backslash escaping. Well, in XML, it's ampersand based escaping, right? And with the semicolon at the end. All right, and if you need to escape then this character here, you just use the LT right there. You don't have the escape the greater than. That would not be a problem. But the opening one, you need to. All right. So this is not okay. You cannot start with a number right there. You cannot use that character in the name of an element either. You cannot yourself create element or attributes names that start with XML in any case. It's strictly forbidden. It's reserved actually, but we'll see why later. So this is not okay, not okay, not okay. Here, this is fine. You can absolutely have digits in your names as soon as it starts with a letter or an underscore. That shouldn't really surprise you if you already know how to program in Python or others, because it's a similar convention to the name of a variable in these languages, right? You cannot start a variable name with a digit either in C or in Python, right? So it's a very similar convention, and I'm summarizing right here. So everything that is in black here is not allowed at all. Everything that is white on a green background, this is allowed everywhere. And the blue ones here, this is everywhere, but not at the beginning, right? So you can have digits, but not at the beginning. A dash is okay, a dot is okay. That's actually not like in programming languages. A dot is okay and a colon is okay. But the colons will explain that they are special. So this is it. So what can you use? Letters plus the underscore, and then digits, dash, dot. That's it, right? Okay, and then I told you we love, yes?
We have a question in the chat. So if we would design an application today which stores data, would we still use XML in some cases, or is there a more convenient option for every use case?
The answer is it depends. And this answer is extremely important because there is no such thing as a technology that is for everything. So JSON is not the solution to everything. XML is not the solution to everything. It really, really, really depends on your use case. XML is going to be great in two cases mainly. First, it's going to be great if what you are storing, the data you are storing, are documents like scientific papers, newspaper articles, blog posts, and so on. XML is absolutely great for that. Right? So that's the first case, because JSON would be very bad for storing that. You could, but it would look very strange. So XML is great for publication-related stuff. That's why it's so popular in the publishing industry. The second thing, the second case where XML is extremely popular, and that's the case, for example, with the tax certificates, the Steuerauszug, and so on. The reason is simply that the JSON ecosystem is not mature enough in order to provide an enterprise level support. So this is why XML is favored over JSON when you need a very strong ecosystem of tools to process all of that XML. It might be that for that second case, where the reason is that the ecosystem of JSON is not mature enough, maybe in 10 years or 20 years, the ecosystem of JSON will have matured enough that then we can start using JSON instead of XML. It just takes time, right? So the ecosystem of XML is much older than that of JSON. It's all standardized by the same institution, the W3C World Wide Web Consortium, the same that standardizes HTTP, HTML, and so on. So this is a very, very strong and mature and stable ecosystem, XML. But JSON, having said that, is growing in popularity because it is much simpler. And this is why a lot of people, including us in our group, are working on trying to mature the JSON ecosystem. That's also the reason why in this course, Big Data, I teach less and less XML every year and more JSON every year. And the reason is that there's more and more JSON tools and technologies that are on the way, right? Including those that we are building. Did I answer your question?
The student said yes. And there's another question. Why is XML so great for publishing data?
It's great for publishing data because this is how it looks when you publish. I will have plenty of more slides, by the way, at the end with actual data stored in XML. And you see that you can, with the elements, reproduce the structure of denormalized data the same way we did it with JSON. You can nest table-like data, tables in tables in tables, can also be emulated in XML. That's the reason. I will show you examples. I have examples for you a bit later. And then it will be obvious for you that XML is good for storing data as
well. Another question is that try to store a web page as JSON. Where would you put the text?
Exactly, that's the reason. why we don't use JSON for when you want to have a publication, something that is something that a human would read. Okay. All right. Okay. Now, brace for the next 10 minutes, because I'm going to throw something at you that I know might not be super easy. Let's say I just want to make you aware of this. It's part of what we have in the ecosystem of XML that we do not have yet in JSON. In fact, right now, the attitude of many in the JSON community is, ha, 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 why do we need that, right? So that's why we don't have it in JSON. The problem is that as soon as you have complex use cases, then you start missing that sort of feature that XML has. So I'm going to introduce you to namespaces in XML to explain why we have namespaces in XML, basically for scaling up when you have a lot of data and a lot of tags and you want to keep it under control. I don't know if they will one day make it into JSON. Maybe there is some opposition from part of the community, I don't know, or maybe at some point there will be a realization that namespaces are actually important when you want to scale. But anyway, let me show them to you. I'll try to be as pedagogical as possible. And of course, as for XML, I'm not throwing everything at you. I carefully curated what I will show you. So it's just a little part of it, just what you need to know, right? Okay, so why namespaces? Namespaces were added to XML a bit later. And the idea is that you might have a data set here and a data set there, and you want to join them and do something with them together. So that might be an XML data set and an XML data set, or maybe a JSON data set and a JSON data set, right? But for now, I'm assuming this is XML and this is XML, right? And I want to do something by joining them, right? That's kind of a normal thing to do when you query data. Now, it might be that the first data set is on computer networks, right? It's a computer network data set, maybe, I don't know, with software design networks or whatever. And then there are of course clients and servers in networks, right? So maybe you're going to have tags like this that are called client, blah, 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 and they mean a network client, means a machine that connects, for example, to a REST API or anything. So you might have this in dataset number 1. Let's now look at dataset number 2. Dataset number 2 is a dataset on customer relationship management. It's a completely different dataset, right? Synonym of customer is clients. So you might have in this data set the tag client. And now you probably start realizing the problem here. Because in the data, we have tags called clients, but these are actually computer clients, network clients. And we have tags called client that are actually customers. So I hope you see that this is a problem because this collides. And when you want to start querying, for example, what if you want to ask for all the clients in the joint data set? Well, then it's a big mess because you can no longer tell what is a network client and what is a customer client, right? So this is the motivation for namespaces. That's the reason why we have them. It's to keep things clean and tidy. Like it's perfect to actually teach that in Switzerland because that's exactly what it's about. It's about tidying stuff. Right? So let's tidy our data sets. How do we tidy our data sets? Well, it's pretty much the same idea as with names of people. Because we have a first name and we have a last name, and then there's also middle names and so on. At least it's not everywhere in the world, but at many places of the world, it's like this. We have a first name and a last name. Why? Because if you only have the first name of a person, that's not enough to identify that person, right? So this is why we have the last name, and then you know who the person is. Well, that's even not always the case, and then you need the middle name and so on, right? But this is just the idea. It's as if here we had the first names of the tags, and we would like to add a last name in order to disambiguate them, right? To know that this is clients in the sense of networks, this is client in the sense of customer, right? And actually, that's pretty much how the last names actually made their way. Like, for example, the most common last name in Switzerland is Müller, right? It comes from a profession, and that's to disambiguate by saying, oh, I mean with this person, the one who is the Müller, or the Smith is also, you know, in English, that's also coming from a profession. Baker is also coming from a profession. So you see, we add that last name to say who we mean. In other countries, the last name is made of the father's first name, right? Also to disambiguate, or we we mean this person, but yes, but the son of this other person, right? Okay. So it's pretty much the same in XML. We are going to have the first name, we call it a local name, that's the first name here. And the last name is going to be this thing right there. I would like to just call it thing for now. It's a thing that is the last name, and that we call the namespace. Now you've already seen that, and that's one less thing to learn. It's the same thing that we saw in the REST APIs earlier. Remember the URLs? So this is what we use. It's not something you would put in your browser. You cannot actually write it as a URL in your browser and go there. It will not work. It's really just a resource identification. It's a resource identifier, right? So we still like to use HTTP nevertheless. That might confuse you, but yeah, that's how it is. It just starts with HTTP. All right. So this is a first name, and this is a last name, except that we call them local name and namespace. And the two of them is the complete name, just like the complete name of a person. This is the first name with the last name like that. Right. So now you could say, okay, let's rewrite. So that's an example where we have equality as the local name, and if that's a MathML namespace, that is a standardized dialect of XML with elements names for mathematic formulas. Right. Okay. Now you might think, okay, let's put last names everywhere in the XML document, right? And that looks absolutely, well, awful and unreadable. But remember that we computer scientists are very lazy. So you might have noticed that this is repeated all over the place. Everywhere, these are mathematics stuff here, equality, apply, square root, blah, blah, blah. But here it's always the same last name. So when you have a family gathering, do you call people with their last name? No, of course not. You call them with their first name because everybody has the same last name, or there are very few last names, right? But it's the same in XML. We do the same thing. We basically just put the last name here just once, and we say, let's give it a name just with an initial of something. It's called a prefix. We bind it with this XML. I told you it's reserved, the XML. So XML namespace M, and then we are lazy. We just use this prefix here. But the prefix is really just a shortcut to that family name just because we are lazy, right? That's all it is. And so the idea is that when you have a prefix here, prefix that's for the namespace, blah, 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 mathml. Here, that's the local name, math. So that's the first name. And the idea is that the binding here is done with this special attribute. It's a fake attribute. It's not really an attribute because the purpose of that is only to say, okay, we are too lazy to write the entire namespace every time. So let's use M to refer to it. All right. So the idea is that whenever you have this XMLNS blah, 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 then you bind a prefix to a last name. All right. It's like when you say, for example, there are nicknames actually. For example, Arnold Schwarzenegger. Some people call it Schwarzi, right? Who call him Schwarzi. So you could consider it that this is Schwarzi and this is for Schwarzenegger. That's just an example. All right. So this here is called the namespace binding. It's just saying that this prefix is bound to that namespace. And so what happens when you see the name of an element is that you look for the colon, if there is one. Whatever on the right is the first name, the local name. Whatever is on the left is the prefix. And the prefix must just be looked up in the binding right there. So this is our last name. So here, that element right there has the prefix M, the local name math, and the namespace that is resolved via this binding mechanism. All right. This is called a Q name for qualified name. Right. So every element and attribute name is actually a Q name. Now, what's important to understand is that the prefix doesn't matter at all. I can put anything I want in the prefix. What really matters is really just the first name and the last name, the local name and the namespace. The prefix is only an abbreviation. It's only a shortcut. It really, really doesn't matter. Only the local name and the namespace matter. So these are exactly the same Q names. They only differ in the prefix, and we really do not care about the prefix. This is just a lazy way of not repeating the namespace. All of this is the same, because only the prefix changes. This is the same as this, the same as this, the same as this. Here I put a long prefix there, and the same as this. This, what happens here, this is the absence of prefix. We don't even have any prefix, but it's still in that namespace because here I'm saying the default namespace is that. So that means that whenever I don't have a prefix in there, everybody has this in this family name. It's like going to a family gathering where everybody has the same last name, and that's implicit. So you only use the first names for everybody. All right. So this is the default namespace again, and it just means there is no prefix at all. Can you see any prefix? No, there is no prefix at all, right? So this is why I put absent in there. All right. So now the way it works in an XML document is that in the top level element, I told you there is a single top level element in an XML document. So in this top level element, this is where we put our bindings. So we say here, okay, prefix foo is for that namespace. And once you have done that paperwork, then you can use prefix foo everywhere in your document. You see, so foo is the abbreviation for that family name, that namespace. And all the elements here, they have different local names, of course. These are the first names, but they all have the same family name, which is the shortcut foo for this. This is the family name. All right. Now, this is for being tidy. In practice, people can actually put these bindings anywhere they want, but we won't do that here. We're in Switzerland. Everything is tidy. Everything is nicely arranged and so on. The only place where we put our namespace bindings are at the top level in the elements. If they are alphabetically sorted, it's even better. It's even tidier. You don't have to, but I like to do that. So I sorted it alphabetically. And you see, you just arrange nicely your namespaces and your prefixes in there. Here I have declared bar and foo, so I could use bar and foo everywhere in the document. And I know that these are the actual family names, right? Another piece of advice, if you don't want to turn things into a big mess, do not change the prefix, because you might have a document here that has, they have the namespace foo here and here, but you see that here the prefix is foo and here the prefix is bar. No, here it's okay, sorry, I didn't pay attention. You notice that the prefix is foo for foo and it's foo for foo. So this is the case where it's tidy, that's well done. We are consistent. I am using the same prefix for that namespace, foo, in here as in here. I'm also using foo. So this is best practice. Try to stick to the same prefix. For example, this mathml namespace that we saw earlier, it's common to use the prefix math, then do it like everybody else, use the prefix math. And that also makes communication easier between humans to try to not change the prefix just because you can. Okay, so this is bad. And obviously, you see here, you see f bar, f foo, and you compare with this, that's basically harder as a human to compare. The computer would manage, right? The computer would resolve it to this and notice that it's the same namespace. But really, for your own sanity and that of your colleagues, do not ever change the prefixes between documents. It's just makes everybody's life more difficult, right? So we try to be careful. All right. So the default namespace should be used alone. You don't have to, but again, this is for keeping things within our sanity and not become crazy. So if I have prefixes as many as you want, if you have a default namespace, just do it only if the entire XML document really has the same family name everywhere, then you can use the default namespace. If you mix this with this, again, you're creating a big mess and nobody understands it anymore, except computers, right? But humans who look at your data set will be lost, all right? So you need to be aware that this is not the same thing. Here, everywhere here, every element is in that namespace. Here, every element is in no namespace at all. There is no default namespace. So you can absolutely have XML documents that do not even use namespaces at all, but then all of these are all local names and there is no namespace at all in there, right? This is for the simple use cases of XML, and this is for the enterprise class use cases of XML where you add the family names. All right, so summary of what I said, there are only 4 cases or types of XML documents that we want to see, at least in this course. And anything else than that, I do not recommend if you have to design data sets. The first case is there's no namespace at all. That's the easy case that I started with in this lecture, right? You just have local names, no colons anywhere, and that's right. That's the easy one. Then you have the default namespace. The only difference with this is that you add this XMLNS with a family name, and that basically is the paperwork for putting everybody here in that family, all right? That's one default namespace. The third case is, if you prefer, one prefix namespace, right? And then you use the prefix everywhere. Or several default, several prefix namespaces. Here I have ABCD. I even like to sort them alphabetically, and then I can use A, B, C, and D in there. only these 4 clean kinds of documents I recommend. Anything else would be allowed, but it would, again, drive people insane because this makes things too complex. So all I ask is that you understand, if you see in real life XML documents, you should understand this, that there's no namespace at all. You should understand that this is all in the same namespace. You should understand that this is all in the same namespace too. And you should understand that there's multiple namespaces. So here, this is basically a family gathering with 10 families. And since there are 10 families, then they can just not call themselves Peter or John, right? Because they might be John from this family and John from that family and so on. So this is the family gathering where everybody has to use the last names in order to recognize each other, right? So this is why we have all these plethora of prefixes right there. Okay, so what I want you not to do, that's super scary. I don't even want you to look at that. Do not ever do that. That's not okay, right? Do not do this huge mess of putting it everywhere, only this way. Okay. Regarding attributes, there's a small thing to know is that if you have an unprefixed attribute, it's not in the default namespace. That's a small detail that some people do not know. So here, these elements here are in this namespace, but the attributes right there is in no namespace at all. It's just a convention, really. I don't really know why this was done that way, but this is how it is. And can anybody see what is wrong in here?
Same URL.
Yeah, it's the same URL here. So that's already not clean, right? So this is not clean, still allowed, but not clean. But you notice that foo and bar have the same family name. They have the same namespace. What does it mean here? Do you see what happens? Foo and bar points to the same family name. Anybody? That's a collision, right? This is twice the same attribute name. Because as I said, the prefix doesn't matter. It's the namespace that does. So we have the same local name, the same namespace, so we have a collision. This is not okay, right? So if you get that, then it means you got namespaces. Okay, I'm leaving that as an exercise. It's a non-well-formed XML document that you can try to fix. You can maybe copy-paste it into Oxygen, which is a software you can download on the ETH IT shop. I strongly encourage you to download the Oxygen software. You can validate and check for well-formedness of JSON and XML there. It's a great sandbox to play with. So try to download Oxygen, put that document in there, and there will be plenty of errors because it's not well-formed. Try to fix it and make it work. This is then the solution. You can come back later. It's written like that, Oxygen. And this is the fixed version of the document. But again, just do it offline on your own, right? So try to, by yourself, find all the mistakes that there are in there. There's plenty of mistakes. And try to use Oxygen to fix them. All right. So it's time to wrap up because now the break is coming. So this is now what XML looks like if you want to represent a table. I promised that to you. You asked the question earlier. This is one record of the table, and this is how you would put it in XML, right? Sale, that's typically the singular version of the name of the table, and then one element for every column. You could, of course, do it with attributes if you prefer, but then it doesn't nest, right? So if you have multiple records, typically what you use is an element in the plural form for the table, and then you repeat, because here it's fine to repeat the same element name, right? For element, it's fine. So you have sale, 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 sale. It's just one for every row of your table, and you have nicely arranged. You see, this here is how you store data in XML, right? You can also format it a bit better if you want to format it better with these spaces and indentation and so on. Looks even nicer. By the way, Oxygen does it automatically for you. You can put that in Oxygen, and then you have some special menu entry somewhere that automatically cleans it up and indents it for you, just like that. Okay, and now the nestedness, like we did in JSON, this is a table in a table. That's the denormalization. Well, in XML, it's super easy to do. You see orders, that's the orders table right there that has 1, 2, 3 rows. First, these are the 3 rows. And this is nested in the sales table, right? So take the time offline to look at that. And you will see that because elements nest in elements, we can nest a table in a table with the XML syntax. So you see that just like JSON, XML is also great for storing denormalized data sets. All right. So let's just tell you, and we'll take the break right after that, that XML and JSON, that's a huge debate. Again, there's use cases for everything. Sometimes you can use one or the other. Just make the decision based on every use case, right? It's really, my goal is just to equip you with what they look like, and then you can make your own decisions. Conclusion before the break, there's even more syntaxes, like this is called YAML, yet another markup language. And here I'm not even telling you anything because you can figure it on your own. Find here what is an array, what is an object, and so on, and try to rewrite that in JSON or in XML as an exercise, right? I'm pretty sure you will have absolutely no difficulty understanding this. All right, thank you very much. See you in 10 minutes from now. We'll start with these super big tables after the break. Thank you.